In the old days, there was a division in computing between centralized and distributed, okay? And in a nutshell, centralized means that there's one central computer that everyone connects to through some device, and they pretty much do most of their interaction with the main computer. So main computer and you had devices that would connect to it. Now, over time, those devices took a different role, all right? Because over time, this might be like how computing was like, I don't know, maybe in the 70s, let's say, all right? These were dumb terminals. And what do I mean by dumb terminals? What I mean is they didn't have any processing power of their own. They were just input-output devices. They were a screen and a keyboard that was connected to a computer somewhere else, essentially. And all the work, all the processing power was in the central computer. All right, let's go ahead a little bit in time to maybe the early 80s, where you had personal computers. So you kind of got to the point where, in addition to having dumb terminals connecting to a central computer, you could actually have PCs connecting. And so on. And then what happened is largely, in some cases, you could have the PCs connect to the central computer and act just like a dumb terminal. So you'd access stuff on the central computer, and the processing would happen here, and your PC just pretty much worked in a mode like a dumb terminal. But you could also have your own applications stored on your PC. And then you can have some applications that ran on your machine that may be connected to a central machine, a server for a database server or whatever. The point is over time, this kind of model is called a client-server model, where on both ends of the transaction you have computers. So you could do some of the work here, you could do some of the work here. But over time, there's always been sort of a flow back and forth between centralized and distributed. Maybe connected to some sort of network. So what does this have to do with what we're doing in this class? We're creating Java programs, all right? So the question we have is how to get our Java applications into the hands of the users, all right? And in doing that, we're going to have to encounter some of the same issues that people had when there was a dichotomy between centralized and distributed. Let's think this through a little bit, and let's think of all the potential issues and so on. Which one do you think is it easier to make updates to? A centralized computer system or distributed? Centralized. Why is that? Yeah, because everything's in one place. You just update the one place and you're good to go. All right. Whereas distributed, you might have to download an application to a bunch of different clients and update it that way. I'll give you a real-life example from, by now it's a while ago. All right. It seems recently, but it was one of my last jobs before I started teaching full-time. And that's where we worked for I did work for a big equipment machine manufacturer. And I did an application, I worked on an application for their field service engineers. And their field service engineers all had laptops. And when they went on site to work on the machines that were needing repair, they would log the information about like what they did, how much time they spent, and so on, and then they would transmit that back to a central machine where they could bill it and so on. All right, as well as keeping a log, so the next time that there was a problem, the field service engineer could look to see the history of the stuff that was done at that site. Okay, it was a nightmare for us to get our application updates out to everyone. Remember, this was pre-internet days. All right, so we would actually send CDs out. Let me rephrase that. It wasn't pre-internet days. It was before web applications were quite as widespread, and whereas connecting to the internet was still a problem, especially given the fact that this is an international company and they could be dealing with engineers around the world. So we actually sent out CDs to the field service engineers. And it was very frustrating for us because by the time we got those CDs delivered to all the people, all the field service engineers, we had fixed things in a release, and yet people were still experiencing the bugs. Why? Because they hadn't had a chance to install the new updates or whatever. All right? So in a distributed environment, definitely it is a more difficult thing to be deployed. Where is security a bigger issue, centralized or distributed? Bigger issue with distributed, why so? Yeah, you have more vulnerability, more access points. All right? Well, that's a good question. It depends specifically on what kinds of vulnerabilities you're talking about. For example, if our field service engineers used a web application as opposed to their application that was installed, their distributed application, all right? If the server was down, everyone would be down, right? If they used a web application. So if, let's say, pick your favorite online service. If Facebook goes down, Facebook's web server goes down, no one can access Facebook. With a distributed application, if someone's laptop goes down, then all the rest of the field service engineers can use the application. So you're right. I would say that's a little bit different than security. That is a case of points of failure. There are fewer points of failure, which is good in one regard, but is bad in another. That makes vulnerability to if there is a fail. All right? So I guess it depends what you mean by security. So deployment is an issue. Security is an issue, and again, it's an issue that cuts both ways. Because in one respect, as you pointed out, if you're securing just one installation, you have a better chance of doing it than securing dozens of applications or whatever. Whereas you're more vulnerable if everything is at one place because all your eggs are in one basket. So this problem today manifests itself, or the solutions manifest itself, in the difference between native applications that you have installed on your machine versus web applications. All right? And there are technologies for putting both web applications that use Java and also native applications. All right? So, now, what's different nowadays with this is there's all sorts of more complicated mixes and matches. All right? In other words, you may have an application on your phone, but it might also connect to a server. So you kind of have a hybrid where part of the application is deployed on your end, part of it is deployed on a web server. Okay? So there's sort of a lot of gray areas that didn't exist in the old days, where it was more clear-cut if something was a distributed application or a centralized application. So let's look at the different ways that you can have Java and you can deploy Java applications, and then we'll talk a little bit about each of them, and then we'll go into more details about all of them or most all of them. First of all, on the web. Web is more like centralized or distributed. Tricky question. It's more centralized because you're typically talking about having your web server that has the code. Okay? So, in a web environment, typically you can develop Java applications which are either going to be JSP pages or Java servlets. Whoops. I'll tell you what. I will. What did I bump? Turn that upper. Why isn't that showing now? Pardon me? Okay, there we go. All right, web applications. They're either going to be JSP or Java servlets in general terms. JSP are essentially web pages that include Java code. Java servlets are Java classes that are web pages. This is kind of like the Reese's cup, right? You know, the Reese's cup commercial where the guy with the chocolate runs into the guy with the peanut butter, and the one guy says, you got chocolate in my peanut butter, you got peanut butter in my chocolate. All right, same thing. Both JSP and Java servlets are technology which combine HTML and Java code. And by Java code, I'm not talking about JavaScript. JavaScript is not the same as Java. So I'm not talking about the JavaScript that is in a lot of web pages. I'm talking about full-blown actual Java. And with JSP, you essentially have HTML pages that contain blocks of Java code. Whereas in Java servlets, you have a Java class who outputs HTML. Let's look at a couple quick examples of these. All right, here's a funny one. This is a web page that dynamically tells you whether or not you're going to have a good day or not. And it's based on the assumption that 95% of the time you're not going to have a good day. This is pessimistic, right? So, notice what you have. This is a JSP example, and it's Java inside of HTML. So we have our basic HTML page, basic tags that you've seen if you've taken any web development classes. HTML tag, head tag, title tag, body tag. Enclosed in these blocks are Java code. Okay? And in this case, we generate a random number, and we look to see if the random number is greater than 0.95. Because if you remember, math.random gives you a number from 0 to nearly 1. So 0.99999, which is virtually the same as 1. And we look to see if that number is greater than 0.95. And if it is, it displays you'll have a lucky day. Otherwise, it displays, well, life goes on. And then it gives you a link back to where you came from and asking you to try again. Or I'm sorry, a link back to itself so that you could try again. It's a very, very simple example, obviously, but what we notice is that there's Java in the middle of the HTML. In fact, languages like this, and PHP is a similar language to this, you have a weird mix of, you can pop in and out of the programming language anywhere you want to. So right smack dab in the middle of the if statement, we pop out of Java and have a block of HTML. That block of HTML is only going to get hit if this if statement is true, whereas this block of HTML is only going to get hit if this if statement is false. I'm going to see what's installed on this machine, and we might do some simple JSP examples in this class just to get used to the idea. At any rate, it's important to note that with JSP, it's a mix of Java code and included inside a basic HTML page. Modern sites that use JSP. That's a good question. That is another good question. A list of sites that use servlets JSP. This is true, 19 years ago. Most websites implemented in Java are business-oriented, business or financial, It's difficulty to see this due to security issues and so on. Well, that's kind of old. Best 10 JSP hosting. A lot of there are websites that use Java technology in a more extensive way than simply JSP pages. They would use JSP pages along with servlets, servlets, along with an application server to keep track of their problem domain objects and beans and all that kind of thing. Right. Mm-hmm. Yeah, I'm not really so sure about that. This is very difficult to tell. Let's look. Trying to look for something that seems more reliable. IEEE.org would probably be fairly reliable. It's it's a industry organization for engineering. Python, Java, C, C++, R, JavaScript, C#, MATLAB, Swift, and Go. So Java is high up the list. This doesn't differentiate, though, between using it in a web context versus other sorts of contexts. For example, Java is also used with apps in Android development. Python firmly on top, specialized libraries, deep learning. Next comes Java. R is for statistical processing, so it's a very sort of niche language. And look for another. Oh, this is quoting the same IEE thing, which says essentially the same thing. We do not offer a Python course, at least not within our division. Of course, there's a reason. Part of it is historical, that we evolved. We started off offering Visual Basic like maybe 10 years ago, and then maybe, or maybe 15 years ago, we were offering Visual Basic. And then maybe about 7 or 8 years ago, we switched over to C#. All right. That's good for Windows and is good for Microsoft shops. So people that use Microsoft, C# is a good programming language choice. The other main programming language that we teach Java, because Java obviously is very popular on its own, plus Java can be used in mobile development. So that for the Android, that is. So it's popular for that reason. Our other server-side classes, so I'm pretty comfortable with that. The one where we potentially could change and might revise at some point is the CISS226 class, because currently we're teaching PHP. And as you see, PHP is not really on the list. And that would be a good candidate to teach Python in instead. Yeah. Yeah. Yeah, I mean, PHP is still used. I don't know. It's not high on this list. If we look more specialized to web things, we see no, I wouldn't. I think you're misinterpreting me, because they still are used to a high degree. All right. According to this ranking, they're the third most popular. Ruby is good for web stuff too. This ranking, and as you can see, there's really a wide range of rankings for this. JavaScript, no doubt the most trending. Python, Java, PHP. All right. A lot of it has to do with scale too. I would think that on bigger, larger enterprise applications, you're going to see more Java. On the lower end of things, for maybe smaller organizations that want a dynamic site, you're going to see PHP as well. So frameworks free as cost, security, one of the best server side programming languages according to a survey by this. SQL is kind of deceptive to include SQL in here, because SQL is used pretty much regardless of what language you use if you're doing database interactivity. Swift is an iOS thing. All right. So these are good questions. It's always difficult to guess the curriculum and guess what's going to be the best thing in curriculum. And we like to be responsive, but we don't like to be how do I want to say it? We don't want to simply just blindly follow trends as far as the courses we offer. We have an advisory committee, and one of the things that they have emphasized to us over and over and over is if you teach people to become good programmers, it almost doesn't matter what language you teach them, because they can pick up another language and they can do a good job with it. If they understand things like creating classes, creating objects, defining good algorithms, writing good functions, troubleshooting, testing, they understand all those sorts of things, then the language is less important, because you can pick up the language, now granted, when I did this, I was literally, I was a very experienced programmer, but I literally converted a site that I was working on from old school ASP to PHP in like a day or two. And I'd never done any PHP programming in my life. It was just a matter of just going in. Now granted, that was after maybe I'd been working for 10, 15 years, so it was old hat for me. But still, the idea is if you do get very familiar with it, then another language isn't that huge of a deal. Good questions. Java servlets then. Let's see if we have an example here of a Java servlet. Here we go. Notice what we have. We have just a regular old, we don't have an HTML document anymore. We have a Java class. And in it, what we do is, through the use of these println, we're actually sending HTML snippets to the client. Okay? So anything that we have that we're pulling, where we have logic to produce something, to do a calculation, or anything like that, using other classes, all that can happen inside this Java code, and the results of it, just like in your test cases, you did system.out.println. Here you do out.println. The only difference is instead of displaying it on your terminal, you're going to send it to the client. So depending on time, we will probably look at some of these in more detail. Here's JDBC stuff where you can actually do database connectivity and do that, and incorporate that inside of a web page. So that's one end, a Java technologies on the web, all right? And that would include, again, JSPs and servlets. Another option is sort of the distributed option, is where when the application is on each device, so instead of having one centralized place, a web server that you access this stuff, having it on each device would be something like compiling and creating a jar. All right? A jar is an abbreviation for Java Archive. All right? It essentially takes all the class files that you have, all right, and sort of smashes them into one component that you can use to run an application, or it can involve other components as well. It can link up with classes that are in other jars and allow you to run that. Now, if you do that, there's more requirements on your system. You have to have the JRE installed, all right, the Java Runtime Environment. If you remember back to the first couple days of class when we talked about installing Java, we said if you need to install for your machine to develop stuff, you need to install the JDK. Well, to run programs, you need the JRE, because the JRE has a Java virtual machine built into it, and that's what actually is going to run code that exists in these jar files or that exists in your class files. Okay? So that's one requirement. All right? As we move from centralized to a more distributed, typically in the distributed solution, there's more requirements put on each individual device. To access a website that uses JSP, for example, the only requirement is that you have a web browser, right? Do you need Java installed? No. The Java code is running on the web server. So you do not need Java installed to access a website that uses JSP pages. There's minimal requirements then on the client in a centralized system. In fact, sometimes they call these sort of solutions thin client solutions. In other words, there doesn't have to be much on the client. All right? If you compare that with downloading and installing a jar file that contains an application, then number one, there's the burden of downloading and installing that file. And number two, you have to make sure that the JRE is installed. And there's database connectivity, you'd have to ensure that, and so on and so forth. So if it becomes decentralized or distributed, each client then, there's greater demands on the client. Whereas with centralized, there's less demands. I mean, back in the old days with centralized computer systems, you didn't even have a computer at the other end. You had a dumb terminal. And you could do something similar to that today, all right? Whereas you connect just a not very powerful machine at all, as long as it has a web browser, you can access and run web applications. Whereas to install a native distributed application, you would have to have the JRE installed, and more resources on your machine. Now, there's some blurring between this. The one advantage that native applications would give you would be that you don't necessarily have to be connected to the internet to run them. You can run them untethered. But these things sort of have converged a little bit, all right? Because distributed applications can also require you to connect to a web server for some of the information, all right? You may have, for example, Facebook on your phone, right? But to get the updates to the latest people that posted statuses or made comments or whatever, you have to be connected to the internet to get that, all right? So one of the advantages historically of this kind of technology is that you didn't have to be connected to the internet. But now, the way that these applications are written, there still is oftentimes a requirement of having a connection to do certain things at least. All right? Like on my phone, I could connect to Facebook, but I won't see the latest updates if I'm not connected to the internet, if there was a problem with my internet connection or whatever. So in this regard, these things are moving together. It used to be, again, that the one disadvantage that web applications had is that if the internet was down at an organization or whatever, then no one could access the application. Whereas some of those problems actually have migrated into the way distributed applications work. So even though the application is local, there's still resources that are in the cloud that you have to access. And if there's an issue connecting to the internet, you don't have access to those. Questions about this? Besides compiling and creating a jar, of course, there are Android applications. Let me see if I have Android Studio on this machine. I don't think I do. No. In the lab, there's probably, what room are we in? Yeah, there's probably Android Studio in there. Yeah, that's where we have our Android class. Yeah. But that is one way that your Java application can be written to be deployed. Now keep in mind, it's not like you develop your Java application, then you decide, well, how am I going to deploy it? Part of planning the application is what sort of application is it going to be? Is it going to be a web application? Is it going to be a mobile application? Is it going to be a desktop application? And so on. There's also something kind of weird that I really haven't seen too much called Java Web Start. There used to be something called applets. But applets have sort of gone way out of favor due to security concerns, real and imagined. Let's see if I can even find an applet example. Are applets still used? Well, yes, it is being used according to this. Well, this is 2016. Let's see if we can find an example applet. A Java applet was a full-blown's a bad word, was a Java application that ran in your browser, but it ran on your client machine. So it got delivered from a centralized place, yet the execution was on your client machine. This is not very promising when the links on the Oracle pages tell you that it doesn't exist. So I'm just going to go out and say that applets probably are nothing to worry about anymore. Java Web Start, though, is an example of if any of these are. Okay, here. I think the launch ones are the ones that are. Okay, I'm downloading something. I'm going to say I want to keep it. I might not have the JRE installed in here. No, I must, because I can compile stuff. But you get this little JNLP file. That actually has a description of what to run and what Java class to run. These kinds of things, again, I haven't run any of these lately, so I think a lot of browsers don't really support these anymore. Both Applets and Java Web Start, though, were sort of a middle ground between these two because the files came from the centralized web server, but the code is actually run on your machine, which is different than a Java web application where the code lives and runs on the server. Okay? We're going to look at some of these in more detail. We're going to look at, for example, making a jar. We might look at a simple Android application. We might look at JSPs and Java servlets in more detail as well. So I wanted to sort of introduce you to the range of things, and now for the last couple weeks of class, I want to give you some time to work on the stuff that you have and also have some time to sort of explore some of these technologies and see how they work in a little more detail. All right, any questions? All right, we'll see you upstairs for lab.